Hello folks, I hope you're doing well, and in this video we are going to take a look at machine learning reinforcement learning, and basically we're going to do an implementation of reinforcement learning with the game NIM. Now if you're not aware of the game NIM, what happens in it is basically two players start out with a pile of 1, 3, 5, and 7 blocks in each of the 3 columns, and they take turns removing different numbers of blocks just from one of the piles until basically the last person ends up drawing the last block, and then that person that drew the last block actually loses. And so with this machine learning algorithm, I'll start it right now. And it's actually playing a bunch of training games. The AI is 10,000 times. It's playing itself 10,000 times. And what it's done after 10,000 times is it's learned basically what moves to make. So it's my first move, and let's say I take from pile 0, 1. And the AI is going to make a move. So it took 1 from pile 2, and let's say pile 3, I'll take 2, and the AI chose to take 2 from pile 1, and I'll take 1 from pile 3 again, chose to take 1 from pile 1, and why not, I'll just do 1 again from pile 3, and the AI chose to take 1 again, and pile 3, let's say 1 again, pile 2, and then I will choose again 1 from pile 3, and now the AI took 2 from pile 2, so I'm stuck with the last block, so that means I basically lose. And we can try playing the game one more time. So again, it's playing 10,000 training games against each other. Against itself, I mean. And this time the AI went first and took 1 from pile 3. And I'll just go ahead and take 2 from pile 2, let's say. And now I'm going to try to make a move, let's say 2 from pile 2, and then and I've already lost now. So pile 3, I'll choose 1, and the AI is going to choose 1, and then I'm stuck with the last block again, so I basically lost this time again, expectedly. The AI has played 10,000 times against itself, and basically what happens after it's played 10,000 times against itself, it's learned basically all the permutations of the game, which steps lead to victories, which steps don't lead to victory. And in the algorithm that I wrote for the implementation of this machine learning game, I made sure that even if it knew that taking a certain action did lead to success, it would by chance take another action just so that it would try out all the possibilities. So basically it's mastered all the permutations of this game. And let's try this one more time. So I'm going to take, let's say 7 from pile 3, so 7. And it took 2 from pile 2, and say from pile 2, I'll take 1, and then I'll take 1, and any time that you're stuck in a situation where you have 2 in each pile, you've pretty much lost the game against the AI. So if you take 2 from one pile, then it'll just take 1, and you're stuck with that one. But if you take 1, like here, then the AI will just take 2 from another pile, and that means you basically lost the game. So there you go. That's an implementation of a simple machine learning algorithm, and I hope to see you next time. Thanks.